Welcome everybody to Math 120. This is Probability and Statistics at Horry Georgetown Technical College. I am your instructor for the class. My name is Professor Randy Moser. In Chapter 1, we're going to give an introduction to some of the key topics and items that we're going to need to do in order to do statistics. In Section 1.1, we start with an overview. Statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. Roughly, statistics is oftentimes broken up into two branches. There's the collecting, organizing part of the course, and that's referred to as descriptive statistics. And then the interpreting data in order to make decisions is sometimes referred to as inferential statistics. Throughout the class, a common theme will be keeping track of the type of data we're gathering. Population data is data that is a collection of all responses, measurements, or counts that are of interest. So when you have information or values from all of the responses, that's population data. If we have just a portion or a subset of the population, that's referred to as sample data. For instance, in a survey of 1,000 students from South Carolina technical colleges, were asked if they plan to continue their education at a four-year college. The population for this study would be all SC Tech college students, and the sample would be those 1,000 students that were selected. We can represent this using what's called a Venn diagram, where the population would be the overall rectangle, and then the samples would be subsets, typically represented using circles, that would be contained within that overall population. Okay. We will not be doing a lot with Venn diagrams or set theory in this class, but just know that there are some ways in which you can visually represent populations and subsets. Let's take a look at another one. Suppose we have a survey of 200 HTC students that found that 21% said they enjoy math. For this study, the population would be all HTC students, and the sample would be those 200 students that were selected. Notice we have some additional information, a little bit of noise in this question. That's that number 21%. This 21% is actually describing our sample, and we're going to have a term for that in a moment. This is what's referred to as a statistic. But in terms of the population, it's all tech students, and the sample is just those 200 students that were selected. A few more examples. If we had the annual salary of each pharmacist at a pharmacy, can they say each? That's a synonym for all. So if that has all of the values, then that would make that population data. The age of every third person entering a store, that's some, not all. So that would make that sample data. The soil contamination levels at 10 locations near a landfill. There's obviously going to be many spots, infinitely many, in any geographic region. 10 locations is just some of them, which means that this would be sample data. And then the number of televisions in each U.S. household, if it's in each or all, that would mean that that would be population data. Take a look at a couple more examples. In a survey of 100 U.S. adults, found that 59% think that buying a home is the best investment a family can make. Here, the population would be all U.S. adults, and the sample would be those 100 adults selected. Take a look at one more. At the end of the day, a quality control inspector selects 20 light bulbs from that day's production and tests them. The population for the study would be all of the light bulbs that were produced that day, and the sample would be those 20 light bulbs that were picked for testing. Now that we know what populations and samples are, we're going to start to talk about some descriptors of those two sets, and that brings us to parameters and statistics. Parameters are numbers that describe a population characteristic, whereas statistics are numbers that describe a sample characteristic. The easiest way I find to memorize these two definitions is to know that the two P words go together. So parameters describe populations, and the two S words go together. Statistics describe samples. In the next batch of questions, they ask us to determine whether the numerical value is a parameter or a statistic. As of January 2007, 44% of the governors of the 50 states in the U.S. are Republicans. Here, we have to bring a little bit of extra information to the table. We know that there's only 50 states in the U.S., so having information from all 50 governors means that that would be population data, which means that this number, this 44%, because it's describing the population, that makes 44% a parameter. In a survey of a sample of high school students, 43% said that their mother has taught them the most about managing money. The number that's describing this time is the 43%. It's related to a sample, which means that the 43% is a statistic. In a recent year, the interest category for 12% of all new magazines was sports. That number 12% is describing all of the new magazines. Since it's describing all, that's a population, which means that the 12% is a parameter. We'll do one more. A recent survey of 200 college career centers reported that the average starting salary for media specialists is $43,121. So this number, this 43,000, that's describing this set. First of all, there's way more than 200 colleges out there, and so it's very easy to conceive that there's more than 200 college career centers. So this 200, that would be just a sample, and if the 43,000 is describing a sample, then that means that that number is going to be a statistic.